Okay, so this is my Lab 7 for 2005 Game Physics for Sarah Gowdy. The only script we really worked on actually was our physics engine script, and we just changed two functions here. So we made a new function here called collide spheres, and it checks for a collision between two spheres. First, we calculate the displacement vector from sphere B to sphere A. Then we calculate the distance between the centers of the two spheres. Then we calculate the overlap between the two spheres based on their radii, and we created an if statement in class stating that if there is overlap, the two spheres are colliding. We determine this by calculating the collision normal from sphere B to sphere A, and then we calculate the minimum translation vector, MTV, needed to separate the two spheres. Only then are we able to move sphere A and B apart by half of the overlap, returning true if the collision occurred and returning false if it didn't. Our other function was a branch off of our is overlapping spheres, and we called it collide with plane. And it checks for a collision between a sphere and a plane. First, we calculate the vector from the plane position to the sphere position. Then we calculate the projection of the vector onto the plane's normal to find the position relative to the plane. We create an if statement to determine if the plane is a half space and return false if the sphere is in front of the plane. Inside here, we calculate the overlap between the sphere and the plane. We get the collision normal, we calculate the MTV in order to move the sphere, and then we move the sphere half the overlap distance away from the plane. If the plane is not a half space, we still calculate the distance from the sphere to the plane. Creating an if statement, we say that if the distance is less than the sphere's radii, a collision has occurred. If this is the case, we calculate the overlap, determine the collision normal based on the position along the normal. We calculate the MTV again to separate the plane from the sphere, and we move the sphere away from the plane, returning true if the collision has occurred and false if it hasn't. And if we take a look at what that looks like in our program here, so when we run it, we can see that immediately the two spheres have separated each other. This allows us to be able to push the spheres because they collide with each other and move away from one another. Our plane is able to collide with our spheres and move with all the spheres. And if we select that it is a half space, the sphere that was on the wrong side of the plane will then bloop to the other side of the plane, and the plane can still move all of them. And that's everything. Thanks for watching.